Okay, so the next section in chapter 4 is talking about congruence and triangles. So congruent figures are figures that are exactly the same shape and same size. Okay, so each congruent figure is going to be the same shape and same size as the other figure. So they give you an example for the red figures are congruent because they're all the same shape and size. It doesn't matter their orientation. They could be spun around, flipped upside down, all that good stuff. But if we look to the blue, we obviously have not congruent figures because they're different shapes, different sizes, and so on. When we have two congruent figures, all of the corresponding angles and all of the corresponding sides are going to be congruent. So, for this example here, all right, we have that angle A is congruent to angle P, angle B is congruent to angle Q, angle C is congruent to angle R. Now, in this case, they're marked on the diagram, but that's not always going to be the case, and I will tell you how to know the information without the markings. Okay. Additionally, side AB is congruent to side PQ, side BC is congruent to side QR, and side CA is congruent to side RP. Again, this being marked on the diagram, you can clearly see that without knowing anything about congruent triangles. Now, the way that I can tell which side and which angle matches up with which is by looking at the notation they give me here. So they tell me angle ABC is congruent to triangle PQR. So because A is first and P is first, that means those two are matched up. Okay? B being second and Q being second means those two are matched up, B and Q. Last I have C and I have R, okay? And again, C and R are going to be the pair that are congruent. Do the same thing for sides. I have side AB are the first and second, and side PQ are first and second. And again, this repeats. BC were the second and third, QR were the second and third. CA were the third and first, RP are the third and first. So by given this congruent statement right here, you can automatically know without looking at the picture which sides and angles are going to be congruent. And also one last thing on this is that we can change the order in which we write a congruent statement. For instance, they give us the example BCA is congruent to QRP, and that's because it doesn't matter what order I write the first one in as long as the second one corresponds. So because B is first, its corresponding part, which is Q, has to be first for the second triangle, and so on and so forth. Okay, so for naming congruent parts of congruent triangles, we have triangle DEF is congruent to triangle RST. Again, in this specific problem, we're shown which parts are congruent based on the markings on the diagram, which again we'll get into later is not always going to be the case. So here are our sets of congruent angles, here are our sets of congruent sides, and again that's all just being gathered from the picture itself. For the second example, you're given the congruent statement. The MPLM is congruent to EFGH. So for this one, we don't have any markings on the picture. Now you may be able to look at the picture and kind of figure out which ones are which, but sometimes it's not going to be as simple. So what you do, again, have to look at is my congruent statement right here. Okay, and would match up with E, P with F, L with G, and M with H. So for the first part, they ask us to find the value of X. If we look over here, we see that X is on side GH. Okay, because of our congruent statement, we know that side GH is going to be congruent to side LM. So we look at LM, I have the value 8, which means that I can set up the equation 8 equals 2x minus 3. And using algebra, I can solve that and get x equals 5.5. For the second part, we're looking for y. So if I look at my diagram, I have y is the value of angle E, and E corresponds to angle N, which which is 72 degrees. So then I can set up the equation 72 equals 7y plus 9. And again, using my algebra, I can solve and get y equals 9. These are properties that we've seen throughout the chapters. Okay, reflexive, symmetric, and transitive should again seem very familiar. Reflexive, always saying that something is equal or congruent to itself. So in this case, we have that a triangle is congruent to itself. Symmetric, again, is just where we can flip-flop which side of the equals, or in this case, congruent sign, something is on. And lastly, transitive is when we take three things and relate them together. So if triangle ABC is congruent to DEF, and that same triangle DEF is congruent to triangle JKL, well then we can assume that ABC and JKL are also congruent. So we have some practice problems here. Now you'll notice that we are missing some information, but we could fill that in as we go along. We're told triangle ABC is congruent to triangle TUV. Okay, so right again, if we look just at our figure, whatever measure I have for A should be the same measure I have for T. Now if we look at our diagram, we don't have a measure for either of those, so we're gonna have to find those. B should be congruent to U. So because I have 59 for U, I can assume that B is also 59. And then lastly, C and V also have to be congruent. So since I have C is 55, I can assume V is 55. Now from the triangle sum theorem we learned in the last chapter, we know that all of these angles have to equal 180 degrees in a triangle. So if I have 55 and I have 59, I have a total of 114 degrees, okay, which means that if I subtract that from 180, I'd be left with 66 for my remaining angle. Now it'll be a little bit easier if we go ahead and answer our questions. So angle A is congruent to which angle? We have angle T. Okay, again, A and T. VT, the third and the first, is congruent to which segment? Again, will be the third and the first, so CA. Now we've talked in other sections about how segment CA and segment AC are the same thing. Alright, so in this case, just be careful when we're talking about congruence, you have to name them in the order to which the points will correspond. So I cannot name this AC unless the original statement is TV. Okay. Triangle VTU is congruent to triangle. Okay, so V, we said V corresponds with C. For T, we have T corresponding to A. And then, of course, U would correspond to B. All right, one thing we didn't fill in here was the measure of BC. So again, we look at our letters. BC being the second and third will be the same as whatever UV is equal to. Okay, and in this case, because we do not have a value for UV, we can just fill in that BC would be congruent to the same value as UV. Okay, measure of angle A is equal to measure of angle T, we said earlier. And we also have already solved that to find that it was equal to 66 degrees. Okay. All right. Which of the following statements below can we use to describe the congruent triangles in exercise 10 through 14? So again, all we have to do is go ahead and look to see which ones are in the same order. So for instance, CBA would be 3, 2, 1. So we'll have to look at our other triangle and look and see if it's in the same order, 3, 2, 1. So VUT. So right off the bat, I can already see that A is one that will not work. For B, I have CBA, so again, it has to be in the order 3, 2, 1. Look up here, VUT, 3, 2, 1 will be VUT. So this one is correct. Okay. For UTV, we're going 2, 1, 3. So it would have to correspond to BAC, which it does. So that's also a correct answer. And lastly, for D, I have T, so 1, V, 3, 2, U would have to correspond to 1, 3, 2. Okay, so these will all be answers. The only one that would not be an answer would be A. Okay, we're going to get into these congruent figures. These are proofs, which we are going to get into most likely tomorrow, so don't worry about that. And that's all you have to worry about for tonight.